Testing, testing. Okay, cool. Welcome everyone to the last panel of the day. We know we are, we are between you and the bus, but we'll try to make it fun and entertaining by making it possible for you, if you have questions, to come and actually sit with us and do this as an interactive session. So the session is Industrial Grade AI on OpenStack HPC, Real World Use Case and Future Roadmaps. And hi, I'm Michel. I'm the Chief Technologist and the VP for Infotrend. John Garbutt, go ahead.
Hi everyone, I'm John Garbutt from Stack HPC, Principal Engineer at Stack HPC. Been doing OpenStack since December 2010 kind of time frame, and been doing HPC kind of things for the last 8 years or so.
Yeah, so I'm Armstrong Foundjem. I'm from Montreal, Canada. I'm a researcher in AI. I work with École Polytechnique and the DEAL project. So I'm mostly in the trustworthiness of safety critical systems, which is most of the, we will be talking about the deployment on large scales and industrial grade kind of use cases. Thank you.
Cool. So we prepared a couple of questions because we felt that, as AI practitioner and HPC end users, we always have the same topics that we're trying to cover. So we're going to start with those, and I'm gonna start by asking. Actually, you have the microphone, so John. No, John, stay with me. What different types of AI end user exist in your environments? What are their preferred integration use case? And because it's always a resource sharing problem, how do they share resources?
Okay, thank you. Let me start with that. So the Open Infra AI Working Group has actually recently published a white paper that goes through in detail some of the use cases, which is well worth a look. It's on the Open Infra website. But let's just take a little detour around some of these that we see quite regularly. So I did a talk earlier here about trusted research environments. So there's one of the things that's particularly challenging is how do researchers work on sensitive data. And even though the researchers are working on sensitive data, they still need access to GPUs. So there's the use case of having that encapsulated TRE environment and extending existing TREs into the AI infrastructure. It's a very scientific-y kind of use case. But inside that are all the microcosm of use cases, but a lot more privacy required. That data can't leak, outside of that. So that can change how we approach this. If we look more widely, it sort of applies inside that. Generally speaking, there's a lot of AI research resources at the moment that are still using Slurm for the majority of their use cases. So they're looking more at the batch type workloads and looking at things along the lines of training and other stuff along in the batch sort of frame of reference. But I think increasingly, certainly within one project we're working on the AIR Federation, so the AI research resource in the UK, there's an increasing desire to give data scientists that are trying to do fast model learning a more Jupyter Notebook native experience. They're not used to that Slurm world. So there's been a big increase in trying to get that working faster. So using potentially like, Kube Spawner or running on Kubernetes for that. Increasingly, there's a lot of work to ensure that all of the good practices of infrastructure as code are also applied within the AI space with AI, MLOps. So the MLOps platforms. So for example, Kubeflow is doing a lot of work around, if you look at the Kubeflow training, they're trying to encapsulate templates within the Kubeflow training ecosystem that people can use through a Jupyter Notebook. So you can use the distributed machine learning and the training, fine-tuning profiles, and developing those pieces. And equally, you've got things like MLflow with people trying to encapsulate the repeatable and tracking how your experiments are going and trying to work out what's the best way forward. And what I'm really trying to say is there's a huge ecosystem of things there very often they're interfacing infrastructure in terms of give me a Kubernetes cluster and build things on top.
Can I just ask you just one quick clarification? What type of hardware, accelerators are we talking about in general?
What kind of hardware? All kinds of hardware. So it depends on the various people. If you look at what there's an increasing diversification of hardware for different parts of the AI workload profile. So there is now hardware optimized for inference, there's hardware optimized for all of these different bits, and there is the more sort of general traditional 8-way GPU kind of boxes. There's also an increasingly, there's a diversity of accelerator startups trying to improve different areas of this. So we've got Cerberus with the big wafers. There's GraphCore in the UK pushing their particular hardware approaches. So I think there's an increase in diversity, I would say, in the types of hardware, which can, and there's increasing amounts of ARM tied to the GPU. So it's not just x86. It's not just CUDA, AMD and ROCm, and there's a diversification there.
That's Armstrong.
Over to Armstrong.
Okay. So in the world of AI, we are not only limited to the code. We are talking about a system that is probabilistic, and it has to work in a deterministic environment. For example, what do I mean by that? AI is probabilistic. It builds on the probability of A happening. But traditional software engineering has worked on strict rules. If A, do this, so it's deterministic. But that is not the issue that we want to really focus on. When we talk about large-scale deployment of AI, I want to ask, from what angle do people start having that trust? It is because they have seen the values that a probabilistic system can really impact areas that traditional software could not accomplish. So both works together. And this has led to industrial admiration and attractiveness of AI. One use case that I will mention here is our collaboration with Airbus. We have implanted AI in their configurations in such a way they could do auto landing and taking off. And that models were trained and built on most of the OpenStack cloud platforms that we call Compute Canada. If you look, Compute Canada is the largest infrastructure in Canada that does HPC and AI workloads. It's by no chance to say 2 of the 3 godfathers in AI in the world are from Canada, and all of them works on that platform. They run codes on that platform. That alone should tell us the importance of OpenStack, not only on provisioning VM and doing the formidable work they are doing, but also in the age of AI, how relevant people still rely and trust OpenStack. And those confidence will only grow with strength over time, because as more algorithms are coming up, people need higher infrastructure to test them, to run them, and at the end, they will also need the cloud to deploy them for inferencing. So OpenStack still needs to do much work, but it is already on the right direction. So on that scale, I can assure you and assure ourselves that the industrial scale deployment of AI, from the time of data collection right up to inference, monitoring, and all kinds of feedback, OpenStack can provide that possibilities of doing it, even though it still needs some upgrading in some areas, but that's a good prospect.
Thank you for that, Armstrong. I guess what we're both saying is the researchers need access to infrastructure. Yeah. OpenStack is able to mediate that access to infrastructure, yeah. But equally, the OpenStack interface isn't what these people are using. They're using inference services, they're using notebooks, they're using these platforms we build on top. I think that's fair.
Yeah, the thing is, even if we're like the slum, right? They run clusters of, let's say, experiments. If I have to train a new algorithm, I will want to use Slum so that I can run it, let's say, for 1 month or like 2 months, because we are talking about massive amount of data. I don't want a system that will interrupt, something can happen, it can overheat, and so I need a structure. But then, that is only one aspect in AI. AI is not only about training models. There are several stages along the pipelines. So there are places where we will need the OpenStack core infrastructure themselves. But like what John was saying is, if you ask let's say a researcher or one of the innovators in AI, have you ever heard about OpenStack? Trust me, they can tell you no. But they are using it even when they are answering your question without knowing. Because we don't want to go on the technology beneath. In most research laboratories, be it in the industry or the companies, there is a department, a technical department, that handles everything technical and give us the infrastructure. Yes, if I design an algorithm, I will know at this point, I will need at least 32 GPUs of this kind to run this workload. I've done the math. I need this CPU. I need this amount of RAM. I send that to the technicians. I need this cluster. I don't care to know what is running beneath. I just want a terminal that can give me provision to run my algorithm. And then the next person comes in. So from that perspective, yes, people may not even be aware of it, but that's what we are saying. Compute Canada has this infrastructure of OpenStack Cloud and the Slum, which is spinning AI innovations in the world.
So I think we were going to invite Pierre up now for a sort of follow-on question here, which is, as you said, people need these GPUs, that we need the resources, so does everybody else. How do we share? So one of the things we wanted to talk about, I think, is just to give a little bit of perspective on the Blazar reservations. And you can tell me how to pronounce it properly.
I pronounce it in different ways on different days. So I'm one of the developers and co-reviewers in Blazar, which is the official reservation as a service project in OpenStack. And one of the use cases that we've seen and I've heard about from OpenStack users is with the GPU space. There is a lot of contention for those resources because they are very precious, very expensive. But then when you mediate them with OpenStack and give access to users through VMs, they tend to hold on to them and not let them go. And Blazar is a potential solution because it provides advanced reservations. So you can say, I want a GPU instance, but just between this date, and then at the end of the reservation, the resources are automatically freed and they become available for the next reservation and so on. And this can be potentially combined with some credit system to have some incentive for the users to not hold an infinite reservation, of course, because then that defeats the purpose of having a reservation system. But if you have some kind of incentive for the users to just reserve the resources when they need them, then they can share those GPUs between each other that way. So if that's something that's interesting for you, you can check the Blazar project. That's BLAZAR. It's one of the official OpenStack projects, and you can get in contact with us through Stack HPC, and we'll be happy to collaborate with you if you want to set it up.
And if you want to contribute to the project, you know OpenStack work. You just were in a session on contributing, so please do so.
Thank you, Martial.
Yeah, of course. So I'll also answer the question, but my use cases are slightly different, right? So I'm more on the commercial side. And on the commercial side, what I end up doing is developing solutions that we can provide to our customer, but on totally different hardware, right? Because as you know, on the commercial side, they're like, well, I want to run on that cloud, which is not always OpenStack. So for my use case, it's mostly about being able to provision VMs with specific type of hardware, deploy solutions on top, and make them composable and reproducible. And we all know that having the ability to develop on a VM and create some deployment agent makes it possible for us to actually do that. So my use case is less HPC, more AI related, but also very likely something that most HPC user lack, which is the ability to say, I have a VM, I'm going to stash it, I'm going to bring it back, and then, oh, shoot, now all my requirements are gone. What do I do, right? So with that, we can continue on that, or do you want to go on to another question? I mean,
are there any questions that you would like to bring to the panel? We can go on to the next one if not.
Oh, okay. Oh,
there we go.
Go for it.
Data scientists, they're not going to know enough about the infrastructure. For my use case, we're providing data scientist teams Kubeflow instances, but we're going down the path of trading inference instances, which still causes them confusion. Where do you think it's heading so that you can just have something like Kubeflow and it can determine whether this workload is trading or inference?
So I'll try and repeat that question. So, so data scientists, we give them the OpenStack API. That's not really what they want. You're providing them with Kubeflow instances for inference and training. You're saying, when do we get to the point where we can make that distinction? I think from my perspective, I'm seeing a lot of sites focusing on providing inference services. Mm-hmm. So actually a long-lived inference service that's shared between users, and that exposes something like the OpenAI API. So for example, like a VLLM kind of based service with a AI gateway in front. So I'm seeing increasingly that people are trying to offer those services such that on top of inference, you can layer the additional applications, if that makes sense. So that might be the chat apps, it might be the translation tool, it might be something more along the lines of, something completely custom, let's say. So from the inference side, I think that shared inference service is gaining a lot of traction. In particular, given the acceptable use policies that are common in the commercial solutions, I think there's a lot of institutions wanting to be able to control where their queries are going and what they're used for. So having your own inference service in-house is providing that. That was a very long-winded way of saying I'm seeing a lot of efficiency in GPU usage from having sort of caching instances of well-used models, and then having that fine-tuning that's added in via the API requests with the extra context on top. So in a sense, I think inference I'm seeing more to be as a shared inference service that people are using directly, and then the training is very often it's more around things like capacity block kind of style allocations. Mm-hmm. So it's more about booking a contiguous block of hardware that's got that low latency interconnect between it, or a whole node, or whatever the scale's required for the training exercises. So it's more about the booking of the training. Is that sort of making a bit of sense, or?
Yeah, and I'll just add, because I fight that battle fairly often. There is a massive difference when you have end users that are training versus just inferring. They don't have at all the same requirements. So in our case, it's mostly a matter of being able to allocate resource for the time of the training. Because just like John said, there's a lot of optimizations that are done at the time of inference, because you can cache the model at that point. During training, you have to basically generate new safe answers. But during inference, and actually I've seen that on the Jetstream front end, whereas they have a ton of LLM, and they're running, very large language model, and they are, just spread on PyTorch on multiple nodes, but they are basically dedicated for that. But at that point, it becomes a inference as a service, right? And those resources are always live just for that purpose. So for me, it's more a question of, well, when you're inferring, you have dedicated hardware. When you're training, you have on-demand hardware, right? You have hardware that become reserved for the purpose of the training. So,
yeah, just to add something from a research side of that question, I make mention of AI being probabilistic. I know where I was going also with that, and that applies to part of your concern. Take, for example, you train a model, and you put it, let's say this carton, so this box here is the model. Now it's open for inference. What happens to the model, let's say 6 months after it was trained? Can you have any suggestion, any guess? The performance gracefully degrades without any external factor. That is how AI models behave. Over time, they naturally degrade their performance. So, researchers suggested after a given period of time, you have to retrain the model. And that brings a different perspective. People might be saying, oh, but that will be a lot of waste of resources and things. If you don't do that, your model start giving you wrong predictions. So that is something we should also keep in mind.
Really well into what we were going for our second question, which is what opportunities or challenge do you see arising from the intersection of OpenStack, Kubernetes, Slurm, and AI workloads? That seems to be, a good fit. And how will this impact the future of cloud infrastructure and AI adoption?
Let me just start. I think that's a very insightful question. And when you look at it from the angle of research, by the way, is always looking ahead of time. It carries out new way of thinking that provokes the models to be data hunger and wants more resources. They want more memory, more RAM, more GPU. They're always engraving for these things. But then, you need to know, not every time they are grieving for these things, they really need it. So you have to think optimally how to leverage your workloads in such a way that you have to think of the environment. Because if you just keep on giving what they are asking, might be you can have some result, but at the end of the day, can we pay the price? So that really brings in the aspect of researchers that many people want to get their result, to be the first to invent this. That calls for fast result without thinking holistically of the consequences of that action. So we are guilty in research for this kind of line of thinking. Everybody wants to be the first, so it moves so fast, and then they think the consequences, both from the carbon footprints and many other aspects later on. So what would be that healthy balance? I would suggest that we will need to have a culture of thinking across holistically while moving forward. Then it comes in that aspect, what type of hardware should I really think of using at this time? If my model needs this kind of training, what are the alternatives? Open source is there. They will always give me an insight of some of the right resources. I cannot trust OpenAI reporting their carbon footprints. They have shown me enough evidence that I cannot trust them. Now, if I have to replicate what they are doing, will I have the insight, the APIs, all the types of logging and monitoring to actually report how much carbon footprints I'm consuming? That is where OpenStack and many of the open source products will stand out, will outperform the industrial grade or the proprietary grade. Because at that point, I'm able now to put code carbon and many other indicators to capture all my footprints from the model that I trained. And now I can provision Kubernetes, even during my training, to do some of the monitorings to see some of the works that are going on. For example, I just want to emphasize this. During training at times, most researchers understand that their models are not performing so well. They discover some bias induction happening, but then they will say, they will allow the process to go, and then they start, if it is discovered, they can now start repairing it. There is a new technique that we can now repair the neurons of some of the models' behavior. And then, I mean, I don't want to go into that research so much, but there are always ways of mitigating some of those circumstances, and those will come in handy when you have total control of how your model or your algorithm should run on these different clusters. So you will really know when you really need the Slurm, when you need, let's say, VMs provisioning from OpenStack, you need Kubernetes for deployment, whatever things you do, you will really have total control. And above all, think about the environment. That's very important too.
No, that's great. I think going through this question in my head, it seems a really good time to go back to Thierry's statements in the keynote. Like, how do we be resilient with this massive amount of change that's happening? And how do we collaborate more to be able to help each other in the face of all of these changes? So I think, you know, the open source world is showing we're innovating fast together and understanding these things. So how do all of these things start working together? Well, it's really interesting, like this week, there was, I say this week, this morning, there was a great talk from Kata containers. There were several great Kata containers talks. And there's some great collaboration happening in the room between, well, this is how GPU NUMA affinity is working within Kata. Well, we can reuse this in Nova. Like, how do we collaborate here and get that better? Well, how do we do Kata containers without having to do nested virtualization within a virtualization context? We're looking at how we mix this up. So I think there's going to be more innovation in that as these use cases, how we get the best out of the machines in these use cases becomes much clearer. I'm certainly seeing the need for things like TEEs and removing that dependence on the infrastructure provider being trusted to not have a look in the VM, and starting to get that. That's definitely happening. But how do we make all of this work together and choose the right solutions in the right place? Well, I think we get together, we collaborate, and we show and share what are the success stories, what are the good ways of doing this? Like, what's the good way to make it repeatable? What's the good way of doing that, kubeflow as a service at the right time with the right backends for the right people?
Yeah, and for me, I know two things in particular which are so important. Education of your end users, right? We talk about optimization all the time. We're like, oh, that actually, you don't need 5 GPUs. That's my battle. I mean, I'll be honest. Everybody's like, oh, I need 5 GPUs. I'm like, no, you need that 2 GPUs, and you just need to factor your research differently, right? They have huge HPC clusters. I have a more limited. Okay, they may have a huge HPC cluster. I have a more limited access to resources. So it's always my fight for resources is likely harder than their fight for resources. So for me, it's more having a chance to basically work with the researchers to be able to try to come up with them with actual resource usage. Because I mean, if you're a researcher, you say I need that, right? Well, we give you that, and then you're like, oh, that was not enough, right? It happens. It never happens. We all know that. I mean, but in practice, what happens is that they say I need that. Oh, I use that, right? So they basically use a quarter of what they requested, but then because they weren't sure. So it's a trial and error process, and very often. It's a trial and error process where we can have a question about reservation ahead of time. At least it's been my experience working in that field. So.
We should do a quick time check in terms of catching buses.
Yeah, I think we're at the end of the...
Are there any quick questions before we finish? We can always have a conversation afterwards.
Yeah, we're welcome to talk in the bus.
Yeah. Thanks, everybody.
Otherwise, thank you for coming. Really appreciate it.